Get ready, everyone. Today we have a special treat as we welcome the fabulous Janice Griffin from Quest to the virtual stage. With her incredible wealth of experience and her knack for making complex topics feel like a breeze, Janice is here to share her top secrets for optimizing SQL Server performance. So grab your favorite drink, settle in, and get ready to take some notes. You won't want to miss the insights that she's about to drop. Let's give a warm virtual welcome to Janice.
Thank you for that introduction, Jessica. My name is Janice Griffin, and my presentation is on mastering SQL Server performance with Quest Foglight. Just a little bit about myself. I've been a longtime DBA. I started out with Oracle 3, if you will, back in the day. I've worked with many database types. The ones I've listed here, I've worked with the most. And I've been at Quest going on 7 years now, and I've always specialized in performance tuning. With Quest, I work with Quest tools, showing our customers how to tune their databases, how to make them run. So this is, near and dear to my heart, so I'm excited about talking about Quest Foglight. The focus today, we're going to actually look at some of the new features of Foglight and some of the features that maybe you haven't seen in the past. I'm going to talk about adaptive baselines and change tracking so you can get an idea of how to historically examine your workloads and make some decisions about how to improve those workloads. Then we'll look at key metrics. We'll understand query execution plans. I'm going to walk through how you read an execution plan in Foglight because it's a tabular format, which you may not be as familiar with. And I'll also show you how to bring up Management Studio in Foglight. And then we'll look at weight types. Weight types are near and dear to my heart because if you can figure out what your queries are waiting on in the database, you've got great clues on figuring out how to fix them. And so we'll go through those. And then finally, there's a small add-on to Foglight that I'd like to show you. Many of you may have it already, but it's called SQL Optimizer. Foglight is a great tool of finding where your bottlenecks are and giving you clues on how to fix it. But SQL Optimizer is really a tool that will rewrite your queries or advise on indexes if you need them. So it's a great add-on to Foglight to actually, be able to tune your queries. Okay, let's get started. I'm starting at the global view, and the reason why I wanted to do this because there's a little unknown feature, I think, that's over in the right-hand corner. And you see I've got it circled. It's called Heat Map. And you can actually click on it. The default page of the global view is, of course, the table view. But if you click on the heat map, what you're going to get, and you can actually click on the different tiles up there to focus on different database types. But you can click on the tiles or look at the whole database landscape and see which instances are having the most problems. As you can see there, the big red box there, the biggest one there is SQL Server. It's I think the instance name is SQL Rep, SQL Dist. And basically, the bigger the box, and of course, it's very red, meaning that it has a lot of alarms. Now, on the right-hand side, you can get a list of those alarms, and you can actually delve into them and see what's going on and get some good answers on how to fix them. I just wanted to show you this because I'm not so sure. There's a lot of ways you can move around Foglight, and I just wanted to point that out. There are a lot of little nuances that you can actually see just by paying attention to other things on the screen. This is, of course, the table view. And again, the global view has a lot of information that, again, I want to just, give a refresher. I've actually clicked on the tile SQL Server, so I'm focused on my SQL Server landscape. And you can see several things I've basically pointed out. The workload is what I always look at, compared to all the other workload within my environment. And you can see that top one is, has a fair sized workload. I also noticed the host. You can monitor your host for free when you purchase Foglight for databases. Basically, we use WinRM or we use SSH if it's a Linux box to go out and look at CPU metrics, memory metrics, network metrics. And you can actually go up on the right-hand corner. There's that little hamburger, or I call it a little hamburger menu there underneath Heat Map, that you can click and you can choose all those metrics and change your global view. That's another thing I just wanted to point out because a lot of people would can customize their global screens and may not know that. You can also create your own groups. Up above on the top there underneath databases, there's an all button. If you click that, you can create your own groups if you want to, for production, for development, or maybe you have, several databases that, encompass an application and you want to group those together for a certain application. You can do that in your group level view in Foglight. Finally, another, quick tip on, the global view is basically you have a quick eye there in the middle of the screen. And so I've actually, that little eyeball, I clicked on that and you can get kind of the lay of the land of a certain instance. So this is showing me, the baseline. We have intelligent baselines that go back over 90 days. And it's looking at this hour of this day, of this week, of this month, and it's drawing that shaded line there that shows you that what is normal. And you can see it's kind of spiky right now. It's not, not so normal. Again, you can, if you're monitoring your OS, you'll get baselines at the OS level, as well as you can see your versions of this database and, get the alarms here as well. It's just a quick way to get the lay of the land of how this instance is running at this time and see if it needs any attention. Okay, so now let's get into some of the new features. Now, Query Insights is relatively new. It came out in 6.3. So if you're not 6.3, you don't have this in your environment, but we've actually improved upon it in our latest version, which is 7.3 and might be point release after that. But what is neat about Query Insights is this is something that you can actually go to at the very first step and look across either your entire database landscape, all of your database instances you're monitoring, or you can dial it in to certain what we call domains. So you can see what I've circled up there is SQL Server because I selected the domain for SQL Server. And then I also selected impact. I said, I want to see all the queries across my SQL domain that are taking up more than 5% of the instances, workload. And so that's what impact means. And as you can see there, if you look at the bottom, the least impact it's showing is 5.09%. But my top query across all my SQL Server landscape is actually 47% if you round up. So 47% of the workload of this instance, which is over there on the right hand there, is basically taken up by this one update statement. Update bank table is what it's doing. So this is telling me that maybe I should go look at that, and it dials it in real quickly of what's impacting my environment the most. So one thing you can do, you can actually dial it in by response time as well, elapsed time, executions, just by clicking and, dialing in what you want to see. And you can actually look at, the actual metrics that come back and it'll give you a min, average and max value of that. So this query actually spent on average, if you round up, 29 minutes, min, max, and average all were around 29 minutes. So pretty sluggish query. Another thing, if you notice, next to elapsed time or the execution or response time titles, there's a little tiny eye. It's kind of hard to see. I should have circled it. But if you click on that, it'll give you the definition. So it's a really nice tool to, actually learn what those mean and actually use to quickly find the most offending queries in your database so you can tune them. Once you've done that, you can go and select investigate. And so I want to investigate this update bank query. So I'm going to press investigate. And this is going to take me directly to SQL Performance Investigator. Now, SQL Performance Investigator you can get to many ways. But if you go in through Query Insights, what's nice about it is it'll actually bring up the query you were looking at. So I'm now looking at the most impactful query in this one SQL Server instance. And you can see it tells me it's the update bank statement. I can see, since I'm focused on it in the performance tree view, you can see that it's waiting on lock weight the most, 61%, if you look over at the resource breakdown on the right-hand side. And, that's a lot of locking. From there, you can actually look at top weights events, which we'll do to see exactly what weight type that lock weight is so we can know how to tune it. Then we can also, in the middle of the screen, analyze it, or you can view the SQL text. I often just do analyze because it'll show you the SQL text as well, and it actually formats it, in my opinion, a little better. You can also SQL tune it, which is, we'll call SQL Optimizer, or you can do a comparison. Is this normal? You can answer questions like that. Do we always have locking? So I could compare today, this hour that I'm looking at, with yesterday and see if it's normal. And we're going to do that right now. But first, I want to look at the weight events. So we actually categorize the weight events, the weight types, and we call the categories weight events. And you can see when I look at the weight events, the top weight type is an LCK-MU, or a lock for modified update. And you can see it's about 63% of the total wait time of this query. So it's the top weight for this query. So we definitely do want to go and evaluate the locking issue. So let's go analyze the plan. Now, what I often do before I analyze the plan is I will look for key metrics. And you have select metrics right next to, if you see where I have analyzed plan, I have select metrics. If you click on that, you can actually choose the type of metrics you want to see. Now, my key go-to metrics are the executions, the single response time for one thing. And you see that's quite high, 14 seconds, or if you round up 15 seconds there for response time. I like to look at the executions, as well as logical reads and row count. Now, I don't have row count listed here, but I usually put that in. And if you actually select those metrics, your browser will cookie those so you can, it'll maintain the metrics you like. But I always like to look at logical reads because you see this did over 1 billion logical reads. The executions were not too much, 1,500, for over 1 billion logical reads. And then the time, the response time is not very good. So it tells me it's an inefficient query. So let's go on and look at, the plan. As you can see there, down at the bottom is SQL text. And it's formatted quite nicely. And over on the right-hand side, you can hardly see it, but there's a little blue caret that if you click on that, if it's a long SQL statement in pages, it'll actually fill the screen and you can look through it, and it's formatted quite nicely. But the way Foglight does execution plans is basically it gives you a tabular format. And the way you read execution plans in Foglight is you start at the most indented, step, and that's the first thing it does. So that's the first step. So you can see the most indented is at index seek and the RID lookup. Now, index seek is, it's going out and reading a non-clustered index. But also the RID lookup means that it has to go back to the table and do some work. I always, when I look at an execution plan, when I see RID lookup, I think of that as an unnecessary step, and it's probably taking up some time. So that to me is kind of a red flag, if you will, when I'm looking at an execution plan. It does those two steps, and it actually gets a result set by doing nested loops with those two steps, and then it does a compute, and then finally it does a table update. Now, you can actually get the graphical format of the query if you like that better, if you have Management Studio on the same box where you're looking at Foglight in your browser. In the left-hand corner there, if you just click the open in SSMS, that will bring up this query in and the query plan in SQL or in Management Studio, so then you can actually look at it and see all the graphical view, which I kind of tend to do. I like that better. But Foglight also gives you more information. Operator analysis, basically what Foglight does, it goes out and analyzes the steps that it does, and it tries to find the most expensive steps to point them out to you. And there were two steps that were really expensive. One was, of course, the table update, And it was 60% of the total time of the cost. And the reason why probably is because of all the locking. And then the second expensive was the RID lookup, which, like I said, to me is a red flag, because to me that shouldn't even be a step if it's correctly tuned. So those two steps are most expensive. Foglight actually does look at object analysis as well. So it looks at the objects in the query and says, okay, my most expensive object is the table bank, not the primary key that we're accessing, but the actual table bank. And the two operators associated with is table update and the RID lookup. So that gives me some clues on where to focus when I'm going to tune. Finally, we can ask ourselves, well, this lock looks awful. Did it just start, or, has it been happening? So at this point, you can actually do a compare. And I love this comparison feature in Foglight, because you can compare anyone in the performance tree over on the left-hand side. Any of the dimensions you can compare, and actually compare a baseline against a baseline, or against a different time, or even a different dimension if you want to. So it's just a really handy feature to say, is this normal or not? So as I go and compare this to yesterday, this query, I can see, well, it looks pretty much the same. The teal color is today, and I'm looking at yesterday, if you will, and that's the gray color. And you can see the line across there. It's pretty much the same. But we do a breakdown of the statistics. We actually show you the batch jobs, the programs that is running it, and you can look at the times and see, well, there's not much change. So 10 to 1, this locking has been happening for a while. Just remember, you can compare different dimensions. You can actually compare different instances. So it's a really handy feature to use, not just looking at a SQL statement. But one thing I think is really nice in the right-hand corner down at the bottom is you can say, well, maybe something changed. Now, I know nothing changed in this case because the workload is pretty much the same. But if something did change, you can actually go to change tracking and see the changes. Now, you can get to this change tracking in SQL PI as well. I got there from the compare screen, but you can also get here by going to advanced analytics. And you can see all the changes that happened during this time. And it's listed here on the left-hand side, the different changes that we collect. We collect account changes, data objects. Right now we had 18 different changes to our data objects. And you can read what they are, and you click on the actual description down in the middle of the screen and get exactly what it did. And some tables have been created, some tables have been removed, a database has been removed, so you can actually go through here. I like to look at the baseline or the breakdown of the workload and see when those changes happen. So if you look at that graph, the little dots there are saying when changes have happened, and you can see the workload, and maybe one of those changes actually increased the workload. So it's kind of a neat correlation to look at this always. But as I look through the change tracking list here, I don't see our bank table or the primary key involved in any of the changes. So I know that's not a problem with this instance, but it's always good to check, because a lot of times somebody might drop an index or maybe an execution plan change, and then all of a sudden a bump in the workload can happen. Another thing I'd like to draw your attention to is underneath the change tracking, see the little line that says add change? You have control to add a change here, and I recommend that highly if you are installing a new index, or you had an application change, or let's say you're upgrading SQL Server to a new version. Do that, but then come in here and mark when you did it, because then you can see when the workload changes and if it's changed for the better, or that index that you added actually made it worse. So you can actually see it. It's a great way to track changes that you've made, or that your development has made into production. The other tab on this screen is advisories. And what's nice about advisories, and you can see it's telling us right now that, objects are experiencing lock weights. So you can, and it looks like with that plus sign on the left-hand side, there's a lot of lock weights. So we can actually click into that and get some advisories. And the nice thing about that is look at what it's pointing to. It's looking at our bank table. And it's actually complaining about the primary, the PK index there, which, is spending a lot of time on locking. So that is where the locking is happening with our bank query, our update bank. So what's neat about this, it does give you recommendations on what to do with locks, but more importantly, if you look at next steps, it actually points to other places in Foglight where you can get more information. So the first one is blocking history, and the second one is activity highlights. And we've got some slides here to show that. So if I go back to blocking history, you can see I've got the blocker and the waiters, and there's quite a few blockers and waiters. And you can see over in the right-hand corner what the blocker is running, as well as what the blockee or the blocked process is trying to run. So another neat feature within Foglight that many of you may not know about is the Locked Objects tab. And this is a nice way, especially if you have blocking and locking, to go look at your locked objects, because it's kind of a different view. It's kind of a top-down view of which objects are locking, and also, as you expand that, what SQL statements are involved in that locking. So it kind of, quantifies not only the locking, because as I open up the lock object, you can see which object is being locked the most. And then you can expand on that plus sign there and actually see the actual statements that are causing that. Finally, the activity highlights. This is out there in the middle of the menus always. A lot of times it won't show anything if there's nothing that's out of whack. But since the locking is quite a big problem here, it's saying, did you know that this instance has consumed a lot of locking? Over about 50% was spent in a lock update. And then it breaks it down to how much time each query has been in a lock wait. And you can see that my update bank query is the top one. Okay, so we found our problem, but what are we going to do with it? Foglight's great at pointing things out, but at this point, you kind of have to figure out how can we fix it? And so that's why SQL Tune becomes really important, because SQL Tune, like I said, it's a small add-on, but you can actually have SQL Optimizer, and Foglight will call SQL Optimizer when you press SQL Tune, and it'll take the query out of its repository, pass it over to SQL Optimizer, and then SQL Optimizer will say, okay, what do you want me to do? Do you want me to rewrite the query looking at the data access plans or, the join methods? Or do you want me to just advise on indexes? And so up there, you've got these little icons underneath Optimize SQL, SQL Rewrite. You can see there's these little, like a tuning fork, there's a key. So you can actually tell it with those little icons to auto-tune it, or just, tune it and tell me what you would do. Or you could say, I just want to see indexes, or I want to do both with that, tuning fork and key together. So basically, I told it to auto-tune, and it went out and did that. And the unfortunate thing is it did not come back with much to see. There's no little gold cup. What SQL Optimizer will do is when you tell it to do a rewrite, it'll go out and look at, different ways to rewrite that query. It'll examine, and you can see all of the things it examines, the execution time, the elapsed time, the response time, all kinds of good things, the CPU time, how many buffers, all that. And the little green lights there will show you better. So that alternate query that it created, alternate 4, not difference in elapsed time, because there was, the first one was running okay when it ran it in SQL Optimizer, but the response time was 0.000 where it was 0.001. So actually, it didn't really find anything better. And we can actually do a comparison to see what it did. So here you can see the original is the update statement, and the alternate query 4, basically all it did was change the and or equal to be an and greater than or equal to. So not much of a change. In fact, it just forced the compute scalar in a different place. So it didn't really change the performance at all. Not that this is bad. I mean, sometimes it's not an option of actually fixing the query or adding an index. Sometimes it's a design issue. And that's in case, and this is an example of that, as you see. Basically, this table was a heap. It wasn't a clustered index, and SQL Server doesn't do well with heap. Heap objects basically hold the data unstructured on disk, and very hard to return, very time consuming. And even if you put a primary key on it, it still has to go to all that unstructured data and make sense out of it. And so it's a lot of I/O usually. So what I decided to do is redesign the table. And I created, instead of a heap, I actually put it in a clustered index. Clustered index basically is an organized table which has the data at the, it's a B tree index. It actually has the whole data of the table in the leaf of the index. So it's very efficient. So I recreated the table, gave it a clustered index on bank code. So everything's sitting in that index. And notice my execution plans now. The before, remember we had that ugly RID lookup and index seek and then that table update. Look at the after. There's just one step, and it's a clustered index update. And, basically, that kind of just really changed the whole game in how this query was operating. I also thought, well, it's passing a literal, and SQL Server is really good about caching statements. And I thought, well, I'll make a procedure and parameterize that literal, so it can cache it and reuse that actual statement. And so I created that procedure there, and I gave it a name of bank name update, and just changed it that way. And basically what happened then is you can see no locking. In fact, most of the time is spent on CPU. There's a little latch weight, very tiny. Notice my executions at the bottom. Now we have 175,000 executions. Look at my response time. Instead of 14 or 15 seconds, now it's less than it's 0.01 seconds. So very efficient at this point. A great way to use a comparison feature in Foglight is to show your improvements. And I definitely am one to, actually print off the screens in Foglight if I've improved something and make it known to my manager. You need to tell people how good you are, because nobody usually brags, about you. You have to kind of brag about yourself. So here's a picture of the improvement we just did. What we did was we changed a heap to a clustered index, and then we changed query from the query from passing literals to it to parameterizing and actually using parameters to store the stored procedure, so we can actually cache that. And you can see the difference here. That teal line, that blue kind of bluish teal color there, it's much lower, but it's much more efficient. It was doing 175,000 executions as opposed to the gray workload where it was just doing all the locking. I didn't get all the metrics here, but you can actually see some of the metrics in there, and I would have gotten that if I was going to show that to management and actually brag about yourself, because no one else will. Okay. This is just another example of SQL Optimizer because we couldn't really use it in that instance. So this actually came in from a customer. It was a university. They actually called in and asked us to look at their, problem and try to figure out what was going on. And they were trying to get their billing out. And so I changed it into a little case study and ran it on my machine because I think it tells a good story. they were trying to get their billing out, and basically they had three tables, and so the queries there where they're selecting student name and sign up date from student, and they were joining that on a historical table registration on student ID, and they were joining it on class ID, and they were passing in literals actually. So I changed it just to be SQL tuning, and then they were passing in a date range, which I changed to be yesterday, if you will. And like I said, the registration table was historical in nature, so the cancel flag, if the student dropped or anything or canceled, basically they changed that flag to Y. So we're looking at only real time or recent students only. So canceled equals no to get the current records. You can see how it was running in, Foglight. It was running pretty sluggish, approximately 2 seconds each execution. It had done 3 million logical reads, and it spent most of its time on async network I/O. Now, async network I/O, and this is something that you can go to our Wikipedia. It's out there on the internet if you just Google Wikipedia, and I think you can actually bring it up in Foglight as well. But basically, it'll tell you that async network I/O is either feeding too much data or retrieving too much data for the client to consume. And so, that's something that you can tune usually. It's not a network issue. It's usually trying to either give too much data to the client and they can't consume it long enough, or, that type of thing. It's an inefficient query. And there's clues on how to tune that. But I basically just put it into SQL Optimizer. And SQL Optimizer, it's running with SQL Optimizer. The way it works, it goes out and tests things. And it rolls everything back. You don't have to worry about it changing any data or anything. But it'll go out and it'll create these alternative indexes and, query plans. And it'll run it and it'll test it. So it went out and it ran the original. And you can see that the original was 0.011 seconds, which, is pretty efficient on my machine, but it wasn't that for the university for sure. But notice that it came up with a little gold cup down there, that index 2. It actually found one that was much better. And notice that instead of 0.011 seconds, it now is 0.001 seconds, 0.001. And you can actually see the rationale across all of it. The elapsed times, was that. The CPU time was, unnotable, if you will. And actually, less bytes were actually, received from it. So it actually improved it. So we can actually go and see the comparison of that. We can see the comparison of it as well as we can actually get the index definition. Now, the way indexes are created, SQL Optimizer will actually preface the index with an OPT underscore SX underscore IDX and then some GUID, if you will. And so you can always recognize them out there. It'll, create the index, test it in its own area, and then it'll drop it. So it doesn't affect any actual application processing. It all runs behind the scenes. But then it'll give you the script so you can actually implement it if you decide you want to. Improvement with that, we can see, and this is where the metrics come in. You can see that once I, actually put the index out there, the little teal line really jumped up, and because of the amount of executions it was doing. And you can actually do the rationale of the number of logical reads that it did, as opposed to the execution. So it's almost, 3 times the throughput that it was doing. And basically, if you look at it, it was 4 times faster when it was running. So much better increase in performance. Just something to think about if you don't have SQL Optimizer. It's a nice add-on, and it helps you actually tune your queries. So finally, in summary, focus on the queries that impact performance the most, and, try out query insights. Try, looking at the different domains, setting the impact levels or maybe the response time levels, and, driving it to, getting it tuned. And then look at baselines and the changes that are happening. That'll give you great clues on where to focus. And also, you can see your workloads change over time. We keep over a year's worth of data by default in Foglight, so you can go back and do some review of what is happening over time in your database. Review the key metrics. My favorites are response time, execution, the executions, logical reads, and row count, and then use wait types, to identify the bottlenecks. Think about looking at Waitopedia. If you Google Waitopedia, it has all the wait types out there, and it gives you great clues on how to fix it, as well as it tells you how other people are using, how many other people are getting that same type of bottleneck. So it's just kind of a nice tool to have at your fingertips. And then finally, determine if it's a poorly written query or if it's a database design flaw. Some things you just can't tune, and you have to go back to the drawing board and redo the design of it. And then consider SQL tuning, SQL Optimizer to do the tuning for you. Like I said, it's a small add-on. If you don't have it now, I'm sure you can talk to your sales guy or whoever you work with Quest, and they'll give you a trial to actually try it out. Just a little bit more. I did create a little ebook a while ago. It's called the Zombie Survival Guide. And basically, you could download it. It talks about my tuning, and like I said, I've tuned for years. It not only covers SQL Server, but also Oracle, MySQL, and Postgres. So if you want to download that, that's available to you. So thank you, and I look forward to seeing you, at the next Foglight 101 series. Clay Jackson is going to be speaking, and it's going to be a very interesting one, showing you how to use REST API in Foglight. Thanks again.